first step to solving a differential equation is to try to get rid of these pesky coefficients in front of our differential. So let's try to multiply everything by y and see if we can recognize what we get out of it. So we'll have something like dy over dx minus 2y is equal to negative 2xy squared. Well, we have some sort of a nonlinear function here. We have y squared. So maybe we can use something like a Bernoulli substitution. We can go like u equals y to the 1 minus n. Well, this looks a little crazy, but n is just going to be 2. So that would just be y equals 1 minus 2, which is y to the negative 1. And that's just going to be 1 over y. Well, u equals 1 over y, then y equals 1 over u. And we also can do a du, and that's going to be equal to, let's look at this one, negative y to the negative 2 dy. Now, in our expression, we have dy over dx, so let's try to divide everything by the dx over here. So now we have a dy over dx. We also know that u equals y to the negative 1, so we can replace this whole thing with sort of a negative u squared dy over dx. That's going to be equal to du over dx. But if we want to move this to the other side, then we'll have negative 1 over u squared du over dx equals dy over dx. And now we can plug that in over here. So we get something like negative 1 over u squared du over dx. And then we have a minus 2 times the y, but the y is just 1 over u, so 1 over u. And that's going to be equal to negative 2x, and then y squared, that's just 1 over u squared. From here, we could try to multiply everything by u squared because, well, we have a lot of u squareds on the bottom here. Maybe a negative, so I'll get rid of these negative signs. So you get something like du over dx minus, actually plus, 2u is going to be equal to 2x. And at this point, we have a regular differential equation. We're looking for the integrating factor here. We get the e to the integral of the p of x dx. And in this case, p of x is just 2. So we have the e of the integral of 2 dx, which is going to be e to the 2x. And that's our integrating factor. So that's what we're going to multiply all three of these terms by. So you get something like e to the 2x du over dx plus e to the 2x 2u equals e to the 2x 2x. Now the whole point of that was really to be able to take this left side here and combine it into one derivative. So we have d over dx of e to the 2x times u. And that's supposed to be equal to e to the 2x times 2x. Now we could try to integrate both sides over dx. And if we do that, this is just going to undo the derivative. So, we're just going to get e to the 2x u on this side. But on this side, we might have to use a di method over here, so by parts. So we'll set up like a plus, a minus, and a plus. We'll start with the derivative. We'll go with the 2x, and we're going to integrate e to the 2x. So then we go down to a 2, and then a 0 here. And then this will become, well, e to the 2x, but then we have to divide it by half there. And then we have to do the same thing here. So e to the 2x, and we got 1/4 over here. And we can connect these arrows. And so the answer on the right side is going to be, well, x e to the 2x. And then we have minus 1/2 e to the 2x. And let's throw in a plus c over here. So the left side is going to reduce to e to the 2x times u, because we're just integrating this derivative, such as undoes the derivative. And then on the right side, we have x e to the 2x minus 1/2 e to the 2x plus c. And then we can divide out this e to the 2x all on both sides. So on the left side, we just have u. But what do we know about u and y? We know that u equals 1 over y. And so if we wanted to get y, well, y equals 1 over u. So let's flip this stuff. So that way y is going to be equal to e to the 2x divided by x e to the 2x minus 1/2 e to the 2x plus c over here. Now this is essentially the answer, although it could be potentially simplified to something like 1 divided by x minus 1/2 plus c e to the negative 2x, something like that. But either one of these, that would work. Oh my god.